Now students, I am going to explain there is a relationship between zeros and coefficients of a polynomial. Means what are the relationship are there the in between the zeros and the coefficients of a polynomials. So here I will explain both quadratic polynomial and a cubic polynomial. Means what are the relationship between the zeros of quadratic polynomial with their coefficients and the what are the relationship between the zeros of the cubic polynomial and with their coefficients. Now we'll start with quadratic polynomial. Listen, it's a very important concepts. Now we'll start with the quadratic polynomial. Now quadratic polynomial. Let alpha and beta be the zeros of a quadratic polynomial f of x is equal to ax squared plus bx plus c. You know that this is the general formula, ax squared plus bx plus c. This is the general formula for quadratic polynomials. And for this quadratic polynomials, alpha and beta are the two zeros. Alpha and beta are the two zeros. So if alpha and beta are the two zeros, you know that by factor theorem, if alpha is the zeros of this polynomial, then x minus alpha will be the factor of this polynomial. Again I repeat, if alpha is the zeros of this polynomial ax square plus bx plus c, then x minus alpha will be the factor of this polynomial. By factor theorem already we have studied in your previous classes, 9th classes, you already have studied this one. So similarly, if beta is the zeros of this polynomial, so x minus beta also can be the factor of this polynomial. So by factor theorem, x minus alpha and x minus beta are the factors of the polynomial p f of x. So if these two are the factors, so f of x we can write f of x is equal to x minus alpha into x minus beta. I added here k. Here k is a constant, any constant number. Here k is a constant number, any constant number. So here k is a constant. Why I added here constant? Suppose in this factorization is there like this form, 2x minus 4. If I take here 2 common, so x minus 2 will be here. So here 2 is the constant. So like that, there is a chances of coming of constant numbers, any constant numbers. So that p of x I wrote, f of x I wrote in this form, k into x minus alpha into x minus beta. I can write this form where k is a constant, k is any constant term. K may be 1, k may be 2, k may be 3, k may be 4, any constant terms. K cannot be equal to 0, remember. Any constant terms I can use here. But f of x I can write x minus alpha into x minus beta. Why? Because x minus alpha and x minus beta are the factors of f of x. That means x minus alpha, x minus beta are the factors. So f of x is exactly divisible by these factors. So we can write f of x is equal to k into x minus alpha into x minus beta. But remainder is equal to 0. Because these two are the factors. So similarly, in place of f of x, I can write ax square plus bx plus c. In place of k I wrote, I multiplied this one, x into x square, x into beta x beta minus alpha into x minus alpha x minus into minus plus alpha beta. X I took common, that's why I wrote here alpha plus beta. Similarly, ax square plus bx plus c is equal to kx square minus k into alpha plus beta into x plus k I multiplied here, k I multiplied here, k I multiplied there, k I multiplied. Now comparing the coefficient of x square, x and the constant term on both sides will compare. Here x square, here coefficient of x square is a, here coefficient of x square is a k, so k is equal to a. Similarly here coefficient b is, here coefficient b, coefficient of x, b is equal to, here coefficient of x is k into alpha plus beta, so here minus sign are there, so minus alpha plus beta into k. Similarly c is equal to k alpha beta. So now alpha plus beta is equal to b minus k, you can bring this side, so minus b by k, so is equal to minus b by, in place of k you can write a, so alpha plus beta is equal to minus b by a. That is alpha plus beta is equal to minus, what is b here? B means coefficient of x, b means coefficient of x, a means what? Coefficient of x square, so I wrote coefficient of x divided by coefficient of x square. Similarly alpha plus alpha into beta is equal to, if k will bring this side, c by k, that is c by a, so why a? Because a is equal to k, in place of k you can substitute a, so alpha into beta is equal to c by a. What is c here? C is the constant term, so alpha beta is equal to constant term divided by coefficient of x square. These two formula remember, this is the relation, alpha and beta at the zeros, b and a at the coefficients, so alpha plus beta is equal to minus b by a, alpha into beta is equal to c by a. This is the relation of zeros of a quadratic polynomials with their coefficients. So by taking one example I will make you clear, more clear. Suppose I took an examples, a f of x is equal to 6x square minus x minus 2. This is an example of a quadratic polynomial. Why? Because degree is 2. So I'll find the zeros of this quadratic polynomial. You know that how to find the zeros of a quadratic polynomial by equating the quadratic polynomial as a 0. You have to factorize. After factorization, here 6 2s are 12, we have to splitting the middle term. You know that how to split the middle term. This coefficient, this constant term multiply, 6 2s are 12. Take any two numbers, if you will multiply you will get 12, and by adding or subtracting you will get minus 1. Here no number means minus 1, so you got this one. So 6x square minus 4x plus 3x minus 2, again you can take 2x common, so after taking common we are getting 3x minus 2 into 2x plus 1 is equal to 0. You can write 3x minus 2 can be 0 or 2x plus 1 also can be 0, because both product are coming 0. So if 3x minus 2 is equal to 0, then x is equal to 2 by 3. If 2x plus 1 is equal to 0, then x is equal to minus 1 by 2. So that we are getting here two zeros, two distinct real zeros. Let anyone who can take as alpha and beta. Let alpha is equal to 2 by 3 and beta is equal to minus 1 by 2. What I am doing here? I am verifying the relation. What the relation here? Relation is alpha plus beta is equal to minus b by a. I am verifying here. So find the alpha plus beta. Here 2 by 3 minus 1 by 2. After solving we are getting 1 by 6. So I can write this one minus. I can write here minus 1, so that minus into minus become plus. So I wrote 1 by 6 as minus into, or minus into minus 1 to the power of minus into minus 1 by 6. In place of minus 1 you can write b, because here listen, 6x square minus x minus 2, if we will equate ax square plus bx plus c, you can equate the coefficient. So a is equal to 6, b is equal to minus 1, c is equal to minus 2. So here in place of minus 1 you can write b. So here in place of 6 you can write a, so minus b by a. So alpha plus beta is equal to minus b by a. Verified. Similarly alpha into beta is equal to 2 by 3 into minus 1 by 2 is equal to minus 2 by 6. So minus 2 by 6 you can write. In place of minus 2 you can write c. In place of 6 you can write a. In place of here less than here minus 2 by 6. Here you can write minus 2 by 6. In place of minus 2 you can write C. In place of 6 you can write A. So alpha plus beta is equal to C by A. There is a very important formula here. Here verified. Here less than here. There is a very important remark here. If alpha and beta are the zeros of the quadratic polynomial f of x, then the polynomial is given by f of x is equal to k into x square minus alpha plus beta into x plus alpha into beta. What is this formula? How to use? Where to apply? By taking one example, I'll make your doubt clear. By taking one example, listen here. Suppose there is given two zeros. Suppose 3 and 2 at the two zeros. Suppose 3 and 2 are the two zeros of a quadratic polynomial, and the question is asking find for which quadratic polynomial having these two zeros. Question what? If two zeros of a quadratic polynomial are given, you have to find the quadratic polynomial. That means for which quadratic polynomial 3 and 2 are the zeros. So we know the formula, the polynomial formula. I said polynomial formula is the required polynomial is p of x is equal to, formula is k into x square minus alpha plus beta into x plus alpha beta. Just now I explained. Let alpha is equal to 3, beta is equal to 3. Anything you can take it. As this one you can take alpha, this one you can take beta, no problem. So k into x square minus alpha plus beta 3 plus 2 is equal to 5x plus alpha into beta 3 into 2 is equal to 6. 3 into 2 is equal to 6. So here for this polynomial, let it be constant, or you can take if k is equal to 1. If you take k is equal to 1, any constant value, this one, this is constant. This is the required polynomial. If you take k is equal to 1, then the required polynomial is x square minus 5x plus 6. For this polynomial, if you will find the zeros, you will get 3 and 2 at the two zeros. Understood? Suppose in this polynomial like this form is coming. Suppose k into is coming like that, x square minus 5x by 4 plus 3, like this is coming. So here if we take, if k is equal, actually you can write this is the required polynomial. If we want to solve more, you can take as here denominator how much, the LCM of denominator, here 1, here LCM is 4, you take k is equal to 4. If k is equal to 4 multiply here, k you multiply, that means 4 you multiply, then the required polynomial will be how much? If k will multiply here, k value is 4, so we'll get here 4x square minus, if we'll multiply here 4 into 5x by 4, again 3 into 4 cancel, we'll get 4x square minus 5x plus 12 is the required polynomial. If like this form is coming, here you know everywhere 1 is there, that's why I took k value is equal to 1. Understood? Is it clear?